After exploring bioplastics with Sasha Fishman, she reminded me about recycled plastics and put me in touch with a well-known artist who works in the field of plastics reclamation, Gary Dusek. I was told he runs an organization called Precious Plastic NYC, a group dedicated to repurposing plastic waste. So we went to visit him in his workshop in the Bronx.
Hey, Andrew, how's it going? Nice to finally meet you.
Good to
Coming
meet
in, I'm
you.
just getting set up.
Excellent.
Basically, the goal of all of this stuff that we're doing is to take plastic out of the environment and put it into something that's supposed to be enduring, right? Whatever that is. The larger the object we make, the easier it is to take out of the environment, right? So like little plastic bags and like bottle caps, pretty hard to take out of the environment. We see it, we go to cleanups and we see the shit all over the beach. It's impossible, right? But if I make a big chunk of it, this is actually way easier to clean up. We've been working with completely unsorted ocean trash. We've been starting to do experiments with cleanups. So this is totally super garbage. This is like the filthiest garbage that we could find to try to test the materials. So this is from Yankee Stadium, that cleanup that I volunteered for this summer with Sanitation Foundation. That is Guardians of Flushing Bay. That came right out of Flushing Bay. The cooking process kills all the bacteria, just FYI. So the plastic comes in. We sort it by plastic type. So after it's cleaned and sorted, we shred it. This is an industrial shredder. This is not an industrial shredder, but this is the one that we're going to demonstrate because we can see what's happening. This is a manual injector by Sustainable Design Studio. They're a company that makes these machines in the UK. So this is what's coming out of the machine. Essentially, it's a giant hot glue gun. This is regulating the temperature. There's a thermocoupler here. So every plastic has a different melting temperature, which is why we really want to identify it. We want to avoid smoking of any kind. So this cools fairly quickly. By the time I pull it out of a mold, it's already fairly hard. This is still hot, so I would not touch that with your bare hands. So we will press fit that, a mold. Production molds are generally made out of milled aluminum, so we'll CNC this. Aluminum is awesome in general because it's fairly infinitely recyclable. And so with a car jack, we just press fit. Then I hold it down for 30 seconds. And then we're going to back it up just slightly. That creates a vacuum inside, so plastic can't come out of the barrel. Release, and then back it all the way up. It's starting to get hot. So molding and demolding is what I'm doing like 95% of the time. It's not very glamorous. So this is what's known as a sprue. And I'll take that and I'll throw it in my bin, and that will go be made into something in the future. And then we just trim off this flashing. So oftentimes it'll come out ready to go. So the desire is to A, get it exactly the color that I want it without adding anything, and B, to get it as perfect as possible right out of the mold so I don't have to sand it or cut it or do anything to it. So an extruder, this does the same thing that this does. The difference is that what's driving it is not a plunger that presses down. It's a screw inside that's pushing the material out here. So we use pretty simple molds. It's just like a deal like this. So same process as we're putting particulated plastic in here. It'll probably take 5 to 10 minutes for this to totally fill up. So I'm just controlling the speed of the auger. So this is turning and pushing plastic through here. We can make really long stuff. Like this is the same way that we're making 4-foot beams.
How feasible is it that you like really build a structure or something?
Super feasible.
Yeah.
Yeah. It's being done already. I mean, all those like brown benches that are made out of plastic in the park is recycled HDP. Same plastic, same method. You can totally build structures out of it. And so you can also do cool free form stuff. So this is just an extruder like a 3D printer. If you have heat gloves, you can like manipulate the plastic by hand. So it's like gummy, it's not like liquid. And I can shape this afterwards, although it does behave in unpredictable ways because the outside's cooling much faster than the inside. So then we take the mold off and we let it cool. If you could freeform this all day long. As long as you're being safe with the ventilation, you know what plastic you're working with. With some awareness, you can work with this material very safely, with barely any equipment. And then there's compression, which is done in an oven. I'm actually going to start heating this up as well. You can use something as simple as a toaster oven if you have adequate ventilation. I started with this toaster oven that I found on the street like 8 years ago. So if you all want to take get a little bit of plastic somewhere of all polypropylene and like put your mark on this sheet, we can cook it and then it'll be a token of your participation. What we're doing right now is the same as you would do on a large scale. You just wouldn't be using a toaster oven. Obviously, you would be using a massive machine. Beautiful. And then we'll cook that sucker for like 10 minutes. This is still cooling down. So because of the shrinkage, we can count on this actually sliding right out once it's cool, right? So we're gonna leave that for a little bit. All right, this looks like it's donezo, ladies and gents.
Did you start with this rather than the injectable? Wait, yeah, when did you start with the plastic stuff?
There we go. Generally what I'll do is leave this under compression until it's fully cooled, because what'll happen is it will curl because it's still hot, it's shrinking in different rates.
It's encouraging to see beautiful new objects being created from our waste plastic. These materials can be poured, rolled, injected, and made into almost anything, which is what plasticity is all about.